would like to introduce in our one of the innovative product demonstrations. The innovation title is Metamaterial-Based Invisibility Cloak. My name is Dr. Mohammad Rashed Faruque. I am from Universiti Kebangsaan, Malaysia. Metamaterials are an arrangement of artificial structure elements which are designed to achieve unusual electromagnetic properties. Meta is the Greek words, whereas the meaning is beyond or alter. Material is the materials. Metamaterials means that changing the characteristics of the materials. Exploration of artificial materials for manipulating electromagnetic wave began at the end of the 19th century. Negative permeability, and negative refractive index. Also an electric field intensity vector E, magnetic field intensity vector H, and a wave vector K formed a left-handed triplet, which is opposition to wave propagation in conventional material and labeled as left-handed materials. In this invention, we have to introduce 4 design steps. Number 1 is the metamaterial design. Number 2 is the metamaterial characterizations. Number 3 is the clock design and implementation. Then performance comparison and measurement of the clock. For this invention, during methodology sections, we have to be used normally commercially available software, which is based on the fine integration technique based computer simulation technology CST microwave tool. That one is used to investigate the S parameters for the material. Periodic boundary condition also used for the simulation purpose. Nicholson-Rossouw method was used for checking the characteristics of the material. That one is identified to materials characteristics is positive or negative. So that one is the important factors. The offense switch measurement technique was used. The material will then be used for an electromagnetic clocking device. In this invention, novelty actually wideband epsilon negative and near zero refractive index property with metamaterial. Single layer clock structures, rectangular shaped clock structure, suitable for C-band clocking operation. The clock practically operates, meaning that hides objects over 500 megahertz area in the C-band, large wideband. That means easily hides objects. So that's why this invention is novel and unique. So in this one is our inventive steps I have already introduced. Number 1 is the metamaterial designs. From this slide, figure shows that is split pi-shape metamaterial, which is built on the CST. That means design on the CST, and all of others is the unit cell parameters. These parameters could be introduced in the unit cell demonstrations. And number 2 inventive steps is the metamaterial characterization. That one is the important things for the material is the metamaterial or not. So for the metamaterial characteristics, we have to be always highlighted is the transmission coefficients. But for the antenna or antenna applications and others applications, we have to be always highlighted to reflection coefficient, which is the S11, and transmission coefficient is measured by S21. From this slide figure number 3, we can show is the S11 and S21 simulation and measured results. Look at this S21 and simulation and measured. Both of them is the negativity and coincide to each other. So that means that this result is perfect. And figure number 4 is mentioned about that refractive index. This refractive index also show that negativity seems as a 0. So that's why we have to be called near zero refractive index. Then inventive steps, metamaterial-based clock design. Figure number 5 we have to be mentioned is the 20 millimeter high and 4 millimeter ready aluminum cylinder was taken as an object. And figure number 6 it is mentioned 2 into 2 unit cell. That one is the built on the clock. Why 2 into 2 array or periodic cell? Because metamaterials could not do work as an individual unit cell. when we have to be built on metamaterial always do that periodically arrangement. So that's why in this invention also we have taken this one is the clocking purpose. We have taken this one is the array 2 into 2 array. Then performance checking of the clock. Clock is properly work or not. That one easily identify when we have to be identified as the normalized scattering width. So in this design, we have to be found that normalized scattering width is the 5.18 gigahertz. And this is the important things how to justify this clock is properly work or not. So as a blindly you cannot talk about this. This is the talk working properly. So that's why this is the important things is the identify the electric field and magnetic field identification. So in this figure number 8, that one is the freest switch electric field, but that one is the distribution of the freest switch. That means there is no SPH or something. So after that, figure 9 is mentioned about that this is the bare object. And look at this figure number 10 is the unclocked frequency, and figure number 10A and figure number 10B is the clock frequency. What is the difference? You can see easily. So that's why is it clocked or unclocked? You can I guess easily there. So this this certain frequency may be clocked or unclocked. So this is the important things. Measurement purpose, we have done some of the measurements. So that's why we have to be summarize that this is the perfectly matches the simulation and measurement results. So in this results in here, figure number 11A is that one is the mention of the simulation results. Is that mention simulation clock, bare object, and unclock. So easily identify and also B is the measurement results. So figure B and figure A, both of them simulation and measurement result coincide to each other. So that's why we have to be clarified that in our clock is perfectly working. So that's why this is the important things. This is the finally judgment. This judgment is properly going on. So then you can easily claim, and everybody claim this clock is 100% accurate or not. So this is the final judgment. So total scattering cross section width. This figure number 12 easily identify. See that without that the plain line is the mention about that the numerical, that means simulation, and that one is the black line is the measurement result. So simulation and measurement result is the same with coincide or occupy to each other. So that's why we have to be summarize that in our clocking is the certain frequency is the perfect. So that's one is the concluding is our works, and so that's why we have to be summarize the results. Results is experimental transmittance for the object within the clock shell displays a peak very close to 0 at a frequency of 5.29 gigahertz instead of at the 5.25 gigahertz. That means 5.25 gigahertz is the simulations, but measured is 5.29. That one is almost acceptable because almost the same of the simulation results, and that is nearly same. So then finally, initially we have to claim the some novelty. So novelty is judgment or not. So after that we have to be justified. So that we have to be written in our novelty about the invention. Number one is the metamaterial-based clock, and near zero. So new near zero refractive index material was adopted for designing the clock. The clocking device does not need any external power source, and the clocking device can be used for both the vertical and horizontal operations. The clock practically operations in the C-band of the microfreesium, and minimum 0.10 scattering with achieved, and an aluminum cylinder was hidden by the clock. Before market or potential collaborations, I have to talk about something. Both research are from the new, so that's why they have to know what is the clocking or things like that. That means in an electromagnetic clock, an object is made electromagnetically invisible for a certain frequency. Clocking is usually important for military applications, stealth spotting of aircraft or missile. An object can be made invisible if it does not redirect electromagnetic waves back to the source, or it does not scatter electromagnetic waves in any directions. To clock an object, scattering from the object being clocked is reduced to zero to a certain frequency. So this is those are the new arena of in this research, so that they want to learn what we have to do, what we could do, summarize. So this is the market potential. Actually, why we have to build this invention. The invisibility clock will greatly improve national security by enhancing the stealth capability of military aircrafts and satellites. Now we are working also drone. So about this fitted this invisibility clock. So we have already successfully completed this one. So, but next time we have to introduce this one, and we are trying to focusing not only for single vent, that means event clocking. So we have to try one design could be summarized that CX or KU to band. That means all of the satellite band coverage. We are trying to improve in our quality. So a small square-shaped clock has great impact for secure satellite security. And thanks everyone, and stay safe.